All, this is Chetan from Cambridge. In this video, we are going to see networking in AWS, and this is the most important topic because networking is the thing which decides the security of your application architecture as well as whether your application can scale and how do you design the traffic, the security groups, or say firewalls, and the routing decisions you take. So this is one of the most important topic, and I want you to learn this topic by heart. Okay, so as you know, before jumping into the AWS world, first let's see how the networking happens in physical world, or rather maybe in your company network, how it works. Okay, additionally you have a network which is something like this in your company, right? So this is a private network. We are talking about the private network, right? So okay, this is a private network, and say it's a company A. Okay, now in this private network, when you go to your office, probably you log into your desktops or laptops, and these laptops are connected over a LAN, so something like this. So as you know, all these computers are connected over LAN, and the routing between these computers happen using a device called a switch, right, which typically works at lower level of the networking protocol and works with ARP protocol, address resolution protocol. And so that this machine can talk to this machine over the MAC addresses, right? They can talk to each other because switch handles all the communication. And then in your company you might have similarly other LANs where maybe on another floor or maybe another teams, and their computers are all connected over again another LAN, and there is another switch, right? Okay, but when this machine, say this is machine A and this is machine B, this wants to talk to this, a switch cannot do this because now this you are going out of your network and connecting to some other network, and that's where we need some other device which can handle that traffic, and which we know is called something called a router, right? Now this router can connect the switches, and router works at higher level protocol, maybe IP layer, and it understands the IP addresses so that this machine can talk to this machine over the IP address. And this topology, if you see, there would be multiple such LANs in your company like this, and many LANs all connected using again routers, and then these routers could be again connected, and finally there could be one or more routers which allows an inbound and outbound connection to the internet. Okay, so that means your company has something like this network, and now what we are saying, this is probably a physical network. What we want is we want to simulate this network in Amazon. So if you want to go to Amazon world, right, so this is my AWS cloud, and I want similar network like this, that component in AWS is called a VPC, which is a virtual private cloud. Okay, so let's go back to our presentation. The formal definition of VPC is it's an private cloud which enables the putting the virtual network into cloud, and then you can simulate the physical network. Okay, so this is what I just explained, a traditional network versus a virtual network. We will dig deep into what all these things are, and we will see everything, what are internet gateway, routers, subnets, and everything. So I hope this diagram is pretty much clear. Okay, before we jump into the VPC, I want you to understand this hierarchy. Because as we are starting with our AWS sessions, you might be confused what are regions, what are accounts, whether accounts are within the regions or the other way around. So understand this diagram. As of now, you can ignore this organization stuff, but you can consider you have one AWS account, right? Everybody has this account, and that account, once you have an AWS account, you can use any of the AWS available regions. So there are around 19 regions at moment, out of which maybe 16 you can use. So you can operate in any of the region. For our use cases, typically we will operate in Mumbai region, and North Virginia region sometimes. So every account can operate in any of the region, and then every region has one or more VPCs. That means in one region you can create multiple VPCs. By default, Amazon restrict the count to 5, but you can increase that limit as well. Okay, clear? So let's go ahead. Okay, one more thing. There are a lot of AWS services that we are going to see, and this different AWS services has different scope, which means some services works at account level like billing or IAM, which is identity and access management, and Route 53, which are global services, right? They have the effect on all the regions and all the services which works below that global level. Then there are some services which operates at region level, like S3 bucket. You create a bucket in particular AWS region, or you create a CloudFront or DynamoDB tables. While some of the other services, typically EC2 and RDS, this works at AZ level. As explained earlier, every region has typically 2 or more availability zones. So when you launch an EC2 machine, you either create in say AZ1 or AZ2 or AZ3, because one machine cannot spawn multiple AZs, because AZs are physical data centers. Similarly, databases you create in maybe one AZ on or another AZ. The scope of these services are AZ level. Load balancers, yes, they can spawn across AZs, which means they can send traffic across AZs, and that's the benefit of using load balancer. It can balance the load across the machines, EC2 machines which are across availability zones. So point is, different AWS services has different scope or different level at which they operate. Okay, let's move ahead. So this diagram, probably it's a simple two-tier architecture, or in fact 3-tier architecture, where you have the DNS, it points to the load balancer, there is a web server layer, app server layer, databases. So it's a fairly simple application which you can architect in AWS and use these AWS services to host. So what part we are looking at is this, a virtual private cloud in which we will launch our web servers and application server and databases. So today we are going to see how to design VPC or various VPC components, and how to use them. Okay, so first thing we want to see is make us familiar with the VPC terminologies. Just one more thing here. As I explained earlier, some services works inside VPC and some works outside VPC. So in one AWS region, if you want to launch EC2 machines, you would have to launch inside VPC, or if you want to launch a databases, inside VPC. But some services they are not created inside VPC because they are being managed by AWS. So these services are managed by AWS, right? And you don't have any control where you launch those services. They are in your region but not under a VPC and under your control. Okay, let's move ahead. Let's understand the VPC components. So VPC, this orange area you see is a VPC. The gray area is a region. So imagine we have a Mumbai region, and in Mumbai region I created one VPC. Now VPC is one private address space, like your company's private network. In that network you would have a lot of hosts, that means machines, and machines would have IP addresses. Similarly, VPC is one big address space, and we can divide this address space into a smaller address space, which is called subnetworks or subnets. So here the blue boundaries or blue boxes that you see are nothing but the subnets or subnetworks. One thing to note that subnet and availability zones have one-to-one mapping. That means VPC can be created in the region, and when you create a subnet inside a VPC, you decide which AZ these subnets belong to. So you can create subnet in either say AZ1 or AZ2. Now imagine this is in Mumbai region which has just 2 availability zones. So I can create subnet across, either in AZ1 or AZ2. and I can create as many subnets in AZ1 and as many subnet in AZ2, but one subnet cannot be in two AZs at the same time. It's one-to-one mapping. Okay, so VPC is a big address space, private address space, and then we divide VPC into smaller address space which are called subnets. We will see how to do that. Now every VPC has something called a route table which decide or which takes the routing decision how the traffic has to go in or go out of your VPC. And we would have a lot of rules in the route table which decides whether your machines are going to be accessible over internet or they are private. All those things will be decided by what rules you put in the routing table. So route table takes those routing decisions. Okay, next thing is firewalls. So in any VPC you could have two levels of firewall. A firewall, there is one firewall which works at EC2 instance level, which is called security group, and another firewall which works at subnet level, which is called network access control list. So this both the firewall have different properties and different purpose, which we will see shortly. But thing to remember is security group works at instance level and the network ACL works at the subnet level, which means whatever rules you put into this firewall will be applied to all EC2 instances, and what rules you put to the inside a security group, it applies to only the EC2 instances to which the security group is connected. Okay, so far so good. Okay, just to revise, there is AWS region. In one region there could be multiple VPCs. VPC is a big private address space. We divide VPCs into smaller address spaces which are called subnetworks or subnets. VPC also has route tables which takes the routing decisions how the traffic will flow in or out of your VPCs or your subnets. And then there are two types of the firewalls. One is at subnet level, which is called network ACL, and one is at EC2 instance level, which is called security group. Okay, let's move ahead. A few more components like internet gateway. Now what are internet gateway? This allows the internet connection to your VPC. That means if you want to connect to any EC2 machine inside your VPC from outside, you need to have this internet gateway. So it connects basically internet to your VPC. Typically whenever you will launch your application and you want to host some websites or some web server or web applications, you would have to typically make it public, and so that an outside world can access your application. In that case you would have to put an internet gateway attached to your VPC so that anybody on the internet can connect to your application or use your application. So internet gateway allows that connectivity. One final gateway, another gateway which we want to which I want to mention is virtual private gateway. Now virtual private gateway allows the private connection between Amazon network and your on-premises data center network. Now why do you need this? Suppose you want to have your VPC to be very secure, where you don't want to open any connection over the internet. That means you don't want to put an internet gateway, but still you want to use the applications which are hosted inside your VPC over a private IP addresses. In that case, you can connect these two networks using, say, a VPN connection, and in that case you need a gateway at Amazon side which is called virtual private gateway, and then you can form an VPN tunnels between these two networks so that the machines inside VPC can access machine inside data centers and the other way around. So this also we will see later in advanced networking section. Okay, to reiterate, there is an internet gateway which allows the internet connection to the VPC, and then there is a virtual private gateway which allows the VPN connection between Amazon VPC and your on-premises data center. I hope things are clear. So let's move ahead and understand more about the VPC. First thing we want to see is VPC addressing. So whenever you would create an VPC, you need to give it some address range, and that would be a private IP address range. And if you remember from your maybe a degree days, there was a networking and there was class A, class B, class C kind of addresses, and every class had few rules, like first 8 bits of the IP addresses will be reserved for the network, rest 24 bits will be allocated to the host, like this, right? So those were called class based network addressing. But with the modern thing, now it is classless interdomain routing, also called CIDR notation, in which we represent the IP address ranges, which are IPv4 addresses. So when you create VPC, you also need to give an IP address range in the CIDR notation. Now in that CIDR notation, it would be something like this, and this guy is called prefix of that notation. Now what's the role of the prefix and how to understand this address? Let's see. Before we actually see the CIDR, first let's understand how the IP addresses works. So do you know IPv4 addresses? And those are, they are 32 bits, right? So that means there are total 8 bits, dot 8 bits, dot 8 bits, dot 8 bits. And if you see, they goes up to 0 to 255, dot 0 to 255, dot 0 to 255, dot 0 to 255. So any IP address would have an IP in this range. So the first IP address is like this, and the last IP address could be this, right? And it is like 32 bits, 8 bits, 8 bits, 8 bits, and 8 bits. Okay, now in this address range, if you see, if for example I have these 8 bits, 8 bits here, 8 bits here, 8 bits here, and 8 bits here, or let me just erase this and redraw the things. Okay, so what I'm doing is, now is, suppose I have 8 bits, 8 bits, 8 bits, and 8 bits. Now what I do, as per class A and B and C, suppose I want to have a class A address. Now in that case, class A says 8 bits are reserved for the network and rest of the bits are for the host. That means out of 32 bits, 8 bits are reserved. So how many hosts I can have in class A address is 2 raised to 24. How 24? 32 minus this 8 bits and whatever number it comes to. If it's class B address, first two octets or first two octets are basically reserved for the network. So class B would have 16 bit given to the network and rest of the 16 given to the host. So how many hosts I can have? 2 raised to 16, which comes around 65536. Now if it's a class C address, probably first 3 octets are given to the network. So total how many hosts I can have? Only 8 bits, which comes to 256. Okay, now with modern addressing with CIDR notation, you use similar things, but you represent it in a different way, right? You express the addressing in this form: x dot x dot x dot x slash x. Now this x is called prefix. So for example, if my address is this 10.10.0.0 slash say 16, what does it mean? This means this 2 octet or a 16 bits are allocated to the network and rest of the 16 bits are allocated to the host. So how many hosts can I have in this network? So let's calculate. So first host in this network would be this, right? The next host IP address in this network will be this 2.3.4 up to say 255. Then what I would do, I'll just have these 2 are fixed because I am fixing the 16 bits for the network, but rest I can change. So next would be 1.0, 1.1, 1.2 likewise. So how many addresses I can have? How to calculate this? So 16 bits I have given to the network. So total host, how many bits I have for the host addressing is like total 32 bits minus 16 bits I am giving to the network. So total 16 bits I have for the host, so total host I can have 2 raised to 16, which is 65536. That means if I create a network with this CIDR notation, I can have 65536 IP addresses in that host. Okay, now let's apply this logic to our VPC. So suppose I am creating one VPC in Amazon, and I give my VPC an address range 10 dot. Now this time I can take any number from 0 to 255. So 10 dot 100 dot say 0016. Now with previous calculations, as we are saying, 16 bits are given to the network, so those are fixed for this VPC, but I can have any numbers for these two places. So how many hosts I can have? Again, 32 minus 16 equal to 16 bits I have for the host, and the total number of hosts I would have 2 raised to 16, which is 65536. Okay, now let's take another example. What if I have the VPC with address range say 10.10.0.0/24. Suppose I created VPC with this CIDR notation. Then what would be the total number of hosts in this? Now if you see, 24 bits I am giving to the network. That means this is fixed for my VPC, and I have only this 4th octet in which I can have the host. So how many hosts I can have? Again, 32 minus 24 given to the network. Total bits available for the host is 8. So total number of hosts I can have 2 raised to 8, which is 256. Fine. Okay, now let's apply this analogy, and what I want to do is, now I want to have this VPC which has this many addresses 65536 divided into smaller network address space, which we call subnetworks. Now when I create a subnetworks, I need to decide what should be the size of the subnet. So say I want every subnet of size 256 host. So what's the first address in this VPC? First IP address 10.100.0.0, and what's the last address in this VPC? 10.100.255.255, because we are fixing these two numbers. That means they cannot change for my VPC. So every host would have these two numbers fixed, but they would have these two numbers changing. So first host probably would have this address, and last would have this address. However, we cannot really use these addresses first and last, but just for an time being, just imagine that. Okay, so this is my first address in VPC, this is my last address in the VPC. Now what I want to do, I want to divide this complete VPC address space into smaller address space, which are called subnetworks. And what I want every subnet to be created with size of 256. So I want what will be the IP address in the first subnet. So this is my first address. Now second address will be this, first, third will be this, then fourth, then fifth, likewise. Last address, this subnet should be this. Now this is my say first subnet. Now what will be the next subnet of 256? 10, 100. We already reached up to 255, so we cannot increase it further. So it's 1.0. This will be the second subnet, and this is the first address in the second subnet. What will be the second address in the second subnet? 1.1. Likewise 255. So this is my second subnet now. Likewise, I can go on increasing this number, and I can have multiple subnet, and this would be probably my last subnet, and this is the last address. So how many such subnets I can have in total? If you see, this is one subnet, this is two. Likewise, I can have now 256 subnets, and ultimately if you see the total count, it will be 256 subnets. Every subnet has 256 hosts, so ultimately the total come as 65536 again. Okay, same as your total VPC address range. So what essentially we are doing here is, we are dividing one big VPC address space into a smaller address space of 256 size each subnet. Now let's understand how to notify this 256 size subnets in the CIDR notation. Okay, so let me erase this. Again, I have an VPC with say address 10.100.0.0.16, right, which means this is for the network, this is for the host. Now I want to create a first subnet, so I create a subnet of 256. Now you know, right, if in the subnet you need 256 bit host, 256 is equal to 2 raised to 8. That means 8 bit I need to give to the host and rest of the bit I will give to the network. So how many bits I will give to the network? Equal to 32 minus 8 equal to 24 bits. So CIDR notation, I would have 24 for my subnet. So like this. So my first subnet would have the CIDR address as this. Now what does it mean? That means the first address in the subnet is this, and then you have this first three octet given to the network, and the last octet is given to the host addressing. So next address in this subnet would be 10.100.0.1, 10.100.0.2, likewise 0.3, 0.4, 0.5. likewise we would have the last address in this subnet is this. Now this is my first subnet, right, which has address as this 10.100.0.0.24. likewise what would be my next subnet? So subnet 2, what would be the address? 10.100.1.0/24, which means this subnet starts from this address and then it goes like .1, .2, .3 up to .255, right? So what I mean is, when you create VPC, you can create with a maximum CIDR as 16, so that you can have total IP addresses in this VPC as 65536. Okay, and then you can divide this one big address into smaller size subnets, and those subnets could be of any size. Here we are creating subnet of size 256 each, but you can create even smaller subnet of size 16 also. Okay, so let's take one more example. Suppose I create a VPC again with this CIDR notation, right, and now I want to create subnets, but I want to create smaller size subnet, not 256. I want every subnet to be of size only 16, which is a minimum size you can create. Now if you want to create a subnet of size 16, what should be the CIDR prefix for that subnet? Now let's calculate that. I want subnet of size 16, which is represented as 2 raised to 4, right? That means in my CIDR notation 4 bits I will be giving to the host, and 32 minus 4 equal to 28 bits I will give to the network. Okay, with that analogy, let's always start for the first address and let's put 28 as our first subnet address. Now if my first subnet has this address range, then what will be the last address in this subnet? So let's calculate that. Now I have this is the first address in the subnet, the next address will be .1, .2, .3, but as you see I have only 16 addresses in this subnet, so last address in this subnet will be this. Now this is my subnet, that's it, it's finished at 15 because the size of the subnet was 16. That means the next subnet address would be 10.100.0.15 is over 16/28, and this will go up to 17, 18 up to 31, right? Now this is my second subnet, right? What will be the next subnet? Like 32 to 48 likewise. So I'm not now creating a subnet of 256 size each, but I'm creating a subnet of size only 16 each. This is size of 16, this is size of 16. So how many such subnets I can create in this VPC? We know total addresses I can have in this VPC 65536, and every subnet is of size 16, so whatever this number comes, that those many subnets I can have in this VPC. Okay, so you need to practice it a bit because it is confusing sometimes, but for our demo purpose or whatever we will be using in exercises, what we will do is we will use any of the address range which is given in the presentation for VPC, like 10.10. say 0016, or we can use say 192.168.0016. this is for VPC addressing, or we can have 172.31.0016, right? So maximum size you can have VPC 16. That means if you are creating a with Cidr 16, you can have maximum IP addresses inside VPC, which is 65536, right? So we can create our VPC with any of the Cidr range. Typically I like to create with 10.100.0016, but that does not matter. You can choose your private IP address range, what you want out of these ranges. Okay, and then we will always create subnet with 256 size. That means in this VPC we will always create subnet, first subnet probably with something like this 24. The next subnet we will create is 10.100.1.0/24. then the next subnet will be 10.100.2.0/24. so these are like subnets, every subnet of size 256. We can go on creating such subnets and then launch. So this is my subnet 1, this is 2, this is 3, likewise. So in all our exercises we will be using this kind of subnets. Okay, let's move back to slides. So we have this, and as you can see, the maximum size of the VPC could be 16 and the minimum size could be 28. So if you have creating the VPC with Cidr 28, then only 16 IPs you can use. One more thing which I wanted to mention is in every subnet, first 4 IPs and the last IP address Amazon reserves for its internal routing. Okay, so you cannot use those IP addresses. That means if you are creating a subnet of size 256, only 251 IP addresses you can use, not more than that. If you are creating a subnet of size 16, then only 11 are the usable IP addresses. Okay,